Often, when we talk about a battery, we hear concepts such as watts, watt-hours, amp-hours, which lead to confusion. We tend to mix power, energy, and capacity. We are going to try to clarify this following the first video and the analogy with the water reservoir. Recall from the previous video, we have a voltage in volts, initially fixed and constant, that we assume that it only depends on the materials we use for the fabrication of the electrodes of the battery, and we can assimilate to the height from which the water falls from the reservoir, and a current in amps that we can control just as we control the water flow by opening the gates more or less to let more or less water out. If we multiply the voltage by the current, we have the power. Power is current multiplied by volts, and we measure it in watts. Amp multiplied by volt. This is related to the amount of work per unit of time, 1 second in this case. Remember the work we have to do to convert one type of energy into another. In other words, the work the battery has to do in order to move the car or to power a street light. So how do we now relate the energy stored in the battery to the power it can develop? The energy is the power that the battery can produce multiplied by time it is working. Energy is equal to power multiplied by time. If we have, for example, a standard lithium-ion battery with a voltage of 3.6 volts and we let out a current of 1 amp and the battery takes 1 hour to discharge, then we have that the battery stored an energy of 3.6 watt-hours. Watt-hour is a unit of energy and equivalent to the joule that we talked about at the beginning of the first video. The only thing we have to do is to convert the hour into seconds. This is divided by 3600 seconds. Since the joule is a very small unit, when we refer to energy, we use watt-hours. So in summary, we have the energy that the battery stores in watt-hours related to the amount of work it can do. This is, for example, the distance that the car can travel or the time the battery is on, and the power in watts, which is related to the energy consumed per unit of time, and we measure it in watts, and 1 watt is 1 joule divided by 1 second. If we now take into account the mass, the weight of the battery, we obtain the gravimetric energy density in watt-hours per kilogram. And if we take into account the volume, we obtain the volumetric energy density in watt-hours per liter, which is the energy we are able to store in the battery per kilo or per liter. Or in other words, the amount of work the battery can do per kilo or liter. And with the power, it's the same, but in this case, we refer to the unit of time, the energy that we consume or give per second, and we measure it in watt per kilogram or watt per liter. We have the power density in watts per kilo or watts per liter. Remember, energy, watt-hour, power, watts. So what is then the capacity of a battery? When we look at a cell phone or a car battery, it often tells us that the capacity is 300 milliamps per hour or 300 amps hour. What is this? We'll see this in the following video.